Hi, today we are going to talk about the best way to learn any ML algorithm. Now, as data scientists, we rarely build any algorithm from scratch. In fact, we mostly focus on the practical usability of an algorithm. And so I have devised an 8-step process which focuses on how to correctly learn an algorithm as a data scientist. Let's get started. What we end up doing is getting into the details of how the algorithm works, trying to understand each step and all the mathematics behind it, which gets quite overwhelming. And the focus should be more on how to use it in real world scenarios. Even in interviews, it is very rare that any interviewer would actually tell you to explain a detailed step-by-step process of what the algorithm is doing. The questions generally revolve around how the algorithm can be used in different scenarios and when faced with different situations. So this 8-step process, which I'll be talking about now, basically focuses on these considerations. Now, starting with step one. Step one is how the algorithm works. Whether it's good for classification or regression problems or both, or is it good for unsupervised learning, machine learning problems. But we are not getting into the details and all the mathematics behind it. Having a general idea of what the algorithm is doing is important because we need to know whether it will be applicable in our particular scenario or not. Now focusing on the practical aspects. The first one in that being input data. However good your algorithm is, if you don't give it the correct kind of data that it wants, it's not going to perform well, right? So what the input data should be like? Does my data need to be standardized or scaled? Does it need to be transformed? Whether I need to handle class imbalance? What about missing values and outliers? Do I need to handle it, or will my algorithm take care of it? Because the input data is different for different algorithms. So for the specific one that you are learning, understanding what kind of input data does it require. Now the next step is about model assumptions. Every ML algorithm has some underlying assumptions. This will depend on how the model is performing. Suppose you have given it the best clean data, but the data violates the model's assumptions. Then obviously the model is going to perform poorly. Understanding whether these assumptions are strict or are they flexible, and whether the data complies with it, is another important aspect to consider. So understanding for each specific algorithm what are the underlying assumptions. The next step is about the objective function. Every algorithm has an objective function to either maximize or minimize. And this is the one that actually guides the training process. The objective function affects everything, right from the training process to model interpretability to understanding how to handle errors. Here again, understanding what the objective function is and what are the important parameters to consider in that objective function. So the next one is about hyperparameters. Now, every ML algorithm has multiple of these. And of course, it's not possible to memorize all of that. But knowing which are the most commonly used ones is important. Also knowing which are the most frequently used ranges for each hyperparameter is also good because it helps to control how the model is being trained and how it's being performed. So focus should be on the most important hyperparameters specific to the algorithm that you are learning. So the next one relates to the problems of underfitting and overfitting. For the specific algorithm that you are learning, what happens if the model has overfit the data? Overfitting happens when the model has learned the patterns in the training data so well that it is not able to generalize well on unseen data. Now, this is in fact a very common and interesting and favorite question you would say of interviewers, where they normally tell you, okay, you're using this specific algorithm, but this model has overfit the data. What are the different steps that you would take to overcome this problem? The next one is about interpreting the output. Now, different algorithms give different kinds of output. Like for classification problems, you would either get classes or predicted classes as the output, or you would get output as some kind of probabilities which need to be converted into classes based on certain thresholds. And if that's the case, how are the different thresholds calculated? And then understanding, okay, now that I have the output, how would I know that the output is good enough or not? Then the question would go to evaluation metrics. Like if it's for classification, should I use precision, recall? If it's regression, should I use R squared, MSE? So when I'm understanding or learning an ML algorithm, what kind of output will it give me? And how will I decide whether that output is good enough or not? And the last one is feature importance. Many ML algorithms have inbuilt functions which give us a feature importance score or give us coefficients which we determine which were the most statistically significant coefficients, which help us determine which were the most important features that contributed to the training process. So, understanding how the specific algorithm handles or gives us the information about the most important features in our dataset. So, to summarize, the 8 points to learn any ML algorithm, starting with the how. How does the algorithm work? The second one is about the input data. What kind of data should I give to my model? The third one is model assumptions. The next one is the objective function. Then the hyperparameters. Then how to handle problems of underfitting and overfitting. Then model interpretability. And the last one, feature importance. This is like the holistic approach, and believe me, learning an algorithm in this way will help you tackle very tricky and confusing ML questions during an interview. And also when making projects, when we come across roadblocks of why the algorithm is not working properly, even though we have given it a good data set, a clean data set, we'll be able to identify areas and pinpoint where the problems are actually occurring. So that's it for today. Now, if you enjoyed the content, do like the video, do subscribe to my channel for more tips and tricks related to data science. Thank you for watching. Bye.